So today I am teaching the sequence of functions. Sequence of function is definition. Fn n from 1 to infinity is called a sequence of function if fn is defined for each of n on a domain. Okay, so if a is subset of R, for each point x in A we define the function a to R, and the sequence of all these functions for all n, this is called sequence of function. For example, the function is x by n. Okay, so here n is varying from 1 to infinity, so we get 1 to infinity functions, and each of the function is dependent on x. How? X by n. So from -1 to 1, for each of the fixed x value we will get the function. The second example could be x power n. Now for each x naught, for each fixed point, this x naught represent any fixed point between the interval or between this domain A. So we get f1 x naught, f2 x naught, f3 x naught, fn x naught, and so on. So we get a sequence of numbers. Okay, we say this sequence converges to L naught if there exists a function f such that f of x naught is equals to L naught. So for each of these sequences of numbers, we get, if we get the limits and we put all that limits as L1, L2, L3, L4, in general L naught, then we say that overall this sequence of function is converging. Okay, and this f is called the limit. So this limit is called pointwise limit because we have fixed this point. Okay, now the pointwise convergence. If the question is for find the pointwise convergence, how you will find out? So suppose this example is given as x by n, where x is from -1 to 1. So for each of the fixed n, as n tends to infinity, this x by n for a fixed value between -1 to 1, this goes to 0. So each of the function for a fixed x, whether it is -1 or 1 by 2 or 1 or 0 or any point between -1 to 1, the sequences of numbers will converge to 0. Okay, so in this case the limit function becomes 0 and the pointwise convergence, we get the pointwise convergence. Okay, for the second example, where you have the function as x power n, and for x belongs to whole of the R. Okay, so now there will be two different limits. For x is equals to 0, so 0 power n, you get the limit as 1. For x is equals to 1, for x is equals to 0, you get the limit 0, and for x is equals to 1, you get the limit as 1. Okay, because 0 power n, so all 0 constant sequence, you get limit also 0. For all 1, you get also 1. So even if you talk about only the interval 0 to 1, you get two different limits. Okay, so here also we get the pointwise convergence, not on whole of R, because for whole of R this will become divergent if you take 2 power n. So 2 power n, this will diverge. Okay, so in fact you take it as only 0 to 1, and 0 to 1 you get pointwise function as at 0 it is 0 and at 1 it is 1. Okay, for any x between -1 to 1, xn converges to 0. So if your x is between -1 to 1 open interval, not -1 or not 1, then you get also, because 1 by 2 power n, suppose 1 by 2 power n, as n tends to infinity, this will converge to 0, and so for each point between -1 to 1. Okay, now for any x greater than 0, greater than 1, this xn converges to infinity. At x is equals to -1, at x is equals to -1, you get xn is oscillatory sequence, because you get -1 plus 1 -1 plus 1, so no convergence. Okay, and for x less than -1, again you get xn tends to -infinity. So here we get pointwise convergence only in -1 to 1. So even if you have to consider it up to R, you find out the convergence in different interval for different values of x, and you get convergence only in -1 to 1 open interval. Okay, in fact you can take the close from the right hand side. Okay, now there is one more example for how to find out the pointwise limit. So here is one more example, x square plus nx by n. The function is x square plus nx by n. How you will find out the limit? You will put limit n tends to infinity fnx. If for a fixed x you get the limit, then it will be called as fx, the pointwise limit function. Okay. Now here how you will solve it? You have to take the limit n tends to infinity, so you will cancel out n wherever possible and then you will take the limit. So you will get x square by n plus x. Now x square by n becomes 0 as n tends to infinity and you get x. Okay, so here you get the function fnx as x, which is called as fx. So it is pointwise convergent. Okay, so this is how we see that how to find out the pointwise convergence. Now there are few more examples, and this example are x upon x plus n, x from 0 to 1. Here also you can simplify it and you take the limit. You take the limit n tends to infinity. Your x to cancel out, 1 plus n by x, n infinity. So you get overall 0. So here the function is pointwise convergent function is 0. Okay, and fnx if e power minus nx square. Now here also for a fixed x, when you find out the limit, you get e power minus infinity is 0. So the pointwise limit function is fnx. Okay. In the next, I will talk about the uniform convergence of the sequences of functions.